Welcome to this video on how to make BLE work in Xamarin. We'll focus here on the BLE client or peripheral. This is most useful for mobile phones so that you can connect to IoT devices. As a quick reminder, here you see a slide on the BLE structure. So within a connection, a profile, there'll be different services, and each service has then different characteristics that you can write or read or so. Now, for more details on the BLE structure, etc., I recommend watching the start of this video here, where for ESP32 microprocessor, I give some more insights on the BLE interface and structure itself. Now, let's have a look at the app that we're going to discuss here. It's actually a simple version of the NRF tool. The NRF tool is super useful for analyzing BLE connections. Well, our simple app here just allows you to scan for BLE devices and then explores different services and characteristics, etc. Let me just blend it in briefly. And it'll show all the BLE devices that are available. We select a device, and then it shows all the services that are available within that BLE device. Selecting then a service, it'll show the individual characteristics that are available. And then when selecting a characteristic, it'll show the parameters of that characteristic in the bottom. Just getting briefly rid of the camera here so you can see. And then there's three buttons that we can choose to send or receive data or register for notifications if the characteristic has any enabled. Okay, but we'll get to more details of the app when we discuss the actual code. Now, for this implementation, we're going to use code behind. And yes, James, I know what you're going to say. No logic in code behind. You're totally right there. It's just that if you straight away start with MVVM, it can be rather confusing, especially for people who are less familiar with Xamarin. So let's just start here with code behind. And if you guys want, I'm happy to add another video of how to port that then to an MVVM structure. Okay, now the video is structured as follows. First, I'll give you a short insight of how to set up the Visual Studio environment that we need to program in Xamarin. This by no means represents a complete introduction into Xamarin. For that, I'd like to refer to the many videos online by James Montemagno and various others. But here I'd really like to focus on the BLE functionality and how to work with that. So after setting up the working environment, we're going to then talk through the code and look at how to interface with BLE and how to discover services, characteristics, etc. If you already have your Xamarin set up in Visual Studio, then feel free to skip that introductory part and go straight to the code description. So start here on the Microsoft page. We need Microsoft Visual Studio. So we'll go ahead to Downloads and just download the community version. Now we can choose the packages we want to install. So the one we need for Xamarin is here, this .NET multi-platform app UI development. So we can select that, and on the right and under optional, we also select Xamarin, and then we say install. Installation is done, so let's now launch Visual Studio. First, we'd like to see if the installation was successful and everything's working, so we'll just create a new project. In the top, we search for Xamarin. And we can just select a Xamarin Android app. It now asks us what kind of app we'd like to install. Well, let's just take this single view app and go for it. Straight away, it'll ask to approve the Android SDK license agreement, so we'll go ahead and approve that. So here's the mobile app. Let's now run the Android emulator. The first thing it'll ask is to create a standard emulation phone to run apps on. So we'll just go ahead and create that. So we can now start the emulator. In order to run the emulator, Visual Studio needs a Hyper-V to be enabled. To do this, you can open the Windows task key and search for turn Windows features on or off. Then you get this particular window, and there you see Hyper-V. You need to enable that. And in addition, you need to scroll down and go to Windows Hypervision platform. And that needs to be enabled as well. So we open Visual Studio again after restart, and then in the drop-down, we go to Android Device Manager. And here we see the emulation devices that are available, and we'll go ahead and start this one. Here the emulated device, and now we can run our app on this emulated device by pressing this play button. Okay, so the app is running, but the app now runs on an emulated device on a computer. We want to work with BLE, Bluetooth Low Energy. Now, the emulator does not have BLE. Now, in order to test whether or not our app is working, we'll need to run the code on a real phone. So we'll go ahead and connect our phone with a cable, with a USB cable to the computer, and then run the app on the actual phone. So I wired up my phone, but the most important thing now is to enable USB debugging. In order to do this, you'll need to briefly go to the settings of your phone. Then you go all the way down to About Phone. You select software information, and you need to tap 7 times on build number. Now, I already did this on my phone, but if you do that, then you enable debug mode. Now that you can see that, if I go briefly back here to my main menu, then on the total bottom, you have developer options. So if you select developer options then and scroll down a bit, you see USB debugging, and that needs to be enabled in order to run Xamarin apps directly on your phone. If you then connect your phone, make sure that your screen is not locked, and it will then ask you enable USB debugging, and you should answer, of course, yes. Otherwise, this won't work. In Visual Studio, we can then see the phone by pressing the down arrow key here, and you see here that there's a Samsung phone, my phone, which automatically is added as soon as USB debugging is enabled. So we select that, then we can compile and run it directly on the phone. So let's have a look-see. And there's our app. So with that, our preparations are done. Let's have a look at the BLE code. But before we dive in, I'd like to briefly mention that I largely based the code on code written by Yanks.si. So here's his blog where he gives some really useful information about the Bluetooth interface and the background, etc. The one thing though is that his implementation is a little bit dated. So I updated it and restructured it a little bit, and that's the code that we'll be discussing today. So with that, let's go to my GitHub page. And on GitHub, you'll need to navigate to Xamarin BLE code behind. So now you can go ahead and download this code. And here we are. We can go ahead and open up the ble.client.sln. If you right click on BLE client, we can go to manage new packages. And there we can have a look at the package that we have installed. Now the main package that we have installed is plugin.BLE. That's the plugin that we're going to use to connect to Bluetooth. In order for that plugin to work, we need to ask for the appropriate permissions. That is a little different whether you're using an Android or an iOS device. For the Android device, what needed to be changed was if you open up here properties, then you can go to the Android manifest. That's over here. And in the Android manifest, these permissions were added. Now for modern phones with an Android software version of 31 or higher, these upper 3 should just be fine. But in legacy devices, you will need also fine location and coarse location. I just left them in here, but feel free to remove them if you only use a newer platform. This basically indicates what permissions you can use with the app. But in newer Android releases, you need to specifically ask for permission as well. And for that to really work, we need to make some changes to the main activity.cs as well. And the main changes that were done here was that after the initialization and loading of the app, that's done over here, I added a permissions.requestAsync BLE permission. Now that BLE permission is an additional function that you can find here in the bottom, and that specifically asks for the permission to use Bluetooth Scan and Bluetooth Connect. Those are the two permissions that are required in this app. Now, for our friends with iPhones, you will need to make some changes to the info.plist file. So that's the file over here in the bottom. However, I haven't tried this myself because I don't have an iPhone device. I will add the link in the description below. Please let me know if this worked out for you. Okay, with that we can close the platform-specific folders and now focus on BLE.client, which is in essence the main app that we're discussing today. The app starts in App.xaml. Now, in the XAML file itself, you can set some general properties. You see here that I set color for the background and color for the labels and entries, etc. Then there is a code behind. And if we look at the code behind, the only thing that the code behind really does is it navigates you through to your first real view page, a content page. So what happens here is we have the constructor over here of the file. So that is basically when this class is created, the function that's run, the compulsory initialize component. And then we create a navigation page, and that navigation page points to BT dev page. The idea of that is Bluetooth, BT, devices, dev page. And we navigate to that page straight away. All the content pages can be found under the views folder. And there you see the typical XAML plus code behind structure that Xamarin always has. So let's now run the code and discuss the functionality of these pages individually. Make sure your phone's connected with USB to your computer, as you will need to run this on your phone because we're using the Bluetooth functionality. Then just select your phone and run play. So I moved the phone now that you can see the Explorer in Visual Studio. And so let's talk through the pages individually. So let's first open up the XAML page itself for the devices page. We first have a button that's defined, that is the scan button, and that's the one that we currently see on the screen. So let's briefly look at the code behind and see what goes on behind the scenes. Here we are in the code behind. We see in the class definition that there's two variables that are being defined within the class. The first one is the iAdapter, Bluetooth adapter. This is the pointer to the Bluetooth interface on the phone. The second one is a list of iDevices that we call getDevice. The underscore is just a naming convention that is a variable within the class. So this list stores then the different BLE devices that are detected. When the page is loaded, then the constructor is called. That is the function over here. This of course starts with initialize component, as always with XAML. And then we first configure the Bluetooth interface and then define a very simple function that whenever the Bluetooth interface finds a new BLE device, that it adds that to this get devices list. Then the next function over here, permission granted async. This is a function because we need to have permission to use the BLE interface, otherwise it won't work. So we'll have to ask the user for permission. Then the next function is scan button clicked. And if we now briefly look into our XAML page, it won't surprise you that when the scan button is clicked, then the scan button clicked function is run. So let's see what happens then. The first step is that the isBusy indicator is set to visible. The isBusy indicator is the round circle that you'll see when you press scan that it shows that it's actually doing something. It then verifies whether it has permission. It then scans for BLE devices and adds them here with the for each, adds them also to the list. But then we also want to see them in a list view in our XAML. And so let me briefly go back to the XAML file. The next thing below the scan button is a list view, and that is found BLE devices list view. And that is the list view that is now populated with the found BLE devices, because we see here found BLE devices list view dot item source equals our devices, and then of course we need to convert this list to an array that it can be shown in the list view. Then it's done, so the isBusy indicator can be set to invisible again. So that's basically all that scan button does. So let's go ahead and click that scan button. The first time you run this code, it might ask you for permission, as it should, but I ran this code already, so my phone was okay. It now found two BLE devices and showed them in the list view. I can now select one of these devices and it will automatically navigate to the next page, namely a page where we investigate how many services that device has, and it will show the overview of services. So how does that work? Going back to the XAML page, we see that item tabbed. So basically if you click on one of these, then it runs the function found Bluetooth devices list view item tabbed. So if I go back to the code behind, you'll find this ridiculously long function name right below. So that's over here. It's hiding a little bit behind the phone, but you can see that the found Bluetooth device list view has an item tabbed event arguments E that as a parameter that it receives. And that is actually the item that was actually tabbed. So the one thing though we need to do is we need to tell now the program that that item that was received is actually an iDevice. So basically a Bluetooth device. And that is done over here. So here this iDevice selected item basically now points to the BLE device that we want to connect to. We verify if the user may be already connected to this device. It could be that you connect the device and just go back and then connect again. So you don't want to try to connect twice. So that's where it checks here. Selected item.state is device.connected. If this is the case, well, we can straight away go to the next page, which would be the Bluetooth services page, so that we can show the services of the connected Bluetooth device. But if this is not the case, then we should try and connect to that BLE device. So that's where we go try, because it may go wrong, and then we need to catch that and display an error. And we set up a connection and then say await Bluetooth adapter.connect to device async. And we pass it, of course, the handle to the BLE device and the parameters that we need to connect to the device. If that goes successfully, then we can navigate to the Bluetooth services page. If that doesn't work out and it throws an error, then we say there was an error connecting. And that's basically it for the Bluetooth devices page. So I can now go ahead and select a Bluetooth device and let's see what services it has to offer. So it now connected to that Bluetooth device and shows the individual services. And it did that by navigating to the Bluetooth services page. So let's go there. The XAML of the Bluetooth services page is very straightforward. So there's basically two things over here. First of all, we display what BLE device we're connected to. And that is just a simple label. And from the code behind, we then write the name of the BLE device over here. So you can see right now already in the code, selected BLE device is ESP32, because that's the one I selected. And then below that, we actually see the services, which is just a simple list view listing the individual services. Now, how do we get those services? That we can see in the code behind. So here's the code behind for the Bluetooth services page. The class defines first two variables. The first one is the device, the BLE device that we're connected to. The second one is the list of services that that BLE device has. The constructor now gets a parameter. We already saw that on the Bluetooth devices page. When we called the Bluetooth services page, we provided the pointer to the BLE device that we connected to. And that's the pointer that it gets here, connected device. And so after our initialized component, the first thing we want to do is store that handle for the connected device to our local variable underscore connected device over here. The next thing we do is we populate now that label that says selected BLE device, in my case now is ESP32. So that is done by updating the text of the label BLE device. The next thing we want to do is we want to populate the list of services with the actual services that the BLE device offers. Now you cannot do this in the constructor of the page. And the reason for this is that we'll need to call an asynchronous function getServicesAsync to retrieve the services that are available. You're not allowed to run asynchronous functions in the constructor. But there's a trick, because there is this method called onAppearing, which is called straight after the page is loaded. And you can override onAppearing and then call those asynchronous functions there. So this way, upon page load, the services will be populated. Now that's exactly what's done over here. We see protected async override onAppearing. And because we're overriding it, we need to first state that it's base.onAppearing, otherwise it won't work. And we can now try to populate the services that the BLE device has to offer. So we say try here and then retrieve the services that are available for the device that we're connected with. Then we have here a bit of a quick hack where we write these services from this read-only file that we retrieve, services list read-only, to our internal variables for the class. Now, there's definitely a better way to do this, so please write this in the comments down below, and I'm happy to update this section of the code. Anyway, we write it now into two variants of these lists. The first one is a list of the actual services. We need that when passing on the right service to the next page. We'll see that in the next function. And then the second variable that we have here is a list of services where we only store the string of the services that are available. And that particular string we then write to the GUI. So if we look in our XAML page, we see that we have a list view that's called found BLE services. And exactly that list view is populated over here with the services list string. So we write the strings to the screen. You could as well, for instance, add the UUIDs of the in particular services. You would do that over here in this for loop, where you could, for instance, say plus UUID and then plus services. Yeah, I gotta scroll a little bit. One moment. Services list read only, and then I.id to string. And if I run the code now, you can see that the UUID has now been updated and is shown as well. Okay, of course, as usual, whenever something goes wrong, we throw an error, display an alert. That's done over here. Then finally, if we now select one of these services down the list, we want to show the characteristics. So let's briefly go to the XAML page. And in the XAML page, we can see that whenever someone actually taps one of these services, then found BLE services item tapped is run. That's the function here at the bottom. Now, because we show actually a list of strings on the screen, we won't get the actual service from the item tabbed event arguments. So what we get is basically that selected item that was selected from the list. So that's where we now need to work with the item index, which basically says you selected the third service from the list. And now we can use our array services list that we populated as well with my quick hack over there, for which we can now select the actual service that we selected using item index. So the item index will say it's the third one, and so services list will then select the third service. We write that to selected service, make sure that it's not 0, and then actually call the Bluetooth characteristics page. The Bluetooth characteristics page, of course, needs two variables in this particular case. First, we need to provide the connected BLE device, and then we want to provide the selected service as well. So let's select a characteristic and go to the characteristics page. Similar to the services page, the characteristics page starts with showing what the BLE device we're connected to and what a BLE service we're connected to. Then it will show us a list of characteristics that are available of the service that we connected to. Let's look at the code behind. Here in this class, we have a few more variables that we define in the beginning. The first one is the connected device, the connected BLE device. Then we, of course, have a connected BLE service. And we then have a list of characteristics that we can show on the screen. The user can now select a characteristic to see the details of that, and that is then this characteristic over here. Here the constructor, and in the constructor, as I already said, we get two arguments from the previous class, that is the BLE device and the selected service. And the first thing after initialize component that we need to do is store those two in our class variables. In the beginning, no characteristic will be selected, so that is null to begin with. Then over here, we populate the labels for the BLE device that we're connected to and the BLE service that we're looking into. These are then shown on the top of the screen. Now we also need to retrieve the characteristics that are available within the service that is selected. And similar to in the services class, we need to now run a asynchronous function, which may not be done in the constructor. So that's where we again override the onAppearing function as done over here, so that we can do a try and run this asynchronous function get characteristics async. We write that in a local read-only variable char list read-only and use the same hack to write that information over to two variables. One is the actual pointer to the list of characteristics, and the other one is a simple string that we'll use to write the characteristics information to the screen. Now the one thing that's missing here again is the UUID. We also added the UUID with the services class just now. Do you think you can add it yourself in this particular line? Let me know in the comments down below. So then finally we write the found characteristics to the screen. If we look into our XAML page, we find that our list view is called found BLE chars. So in the code behind, we take found BLE chars and write the item sources to these list of strings that we just generated. Now, whenever an error occurs, we throw out an error. In this case, I chose a label that can be updated, and that label can be found in our XAML page as well. Of course, that is down below over here. Whenever an error is shown, it gets here shown in red text. It's called error label. And within that error label, I actually also update the time that the error occurred. This is a small function. Let me just scroll there briefly, completely on the bottom, where we take the current time and then return a string with the hour, minutes, and seconds of the current time. So with that, the characteristics are shown on the screen, and we can now go ahead and select a characteristic. If we do so, we can go back to our XAML file. We can see here that the found BLE chars item tabbed function is run. So that particular function is shown over here. We get now the item tabbed event args back from the list of strings. That basically is our list view. And so we need to now correlate that with the actual characteristic that was selected. And that is done over here, where we take our list of characteristics and then take the item index of the selected item to retrieve the actual characteristic that was selected. Now we can fill in some details of that characteristics on the bottom. Let me just select one over here, then we can see what that does. So I selected a characteristic, and on the bottom we see now the UUID. You can see whether you can read or write or update a characteristic, and then there's some descriptors available as well. So how does that work? In our XAML page, we have here a label called BLE char. So that is the label where we write all that characteristics to. Initially it is at no characteristics selected, but then if this characteristic is selected, we update that information over here in this function. We read out all kinds of parameters of this characteristic and write that to the BLE char.text. Obviously, you can change this to your liking. Now we have a characteristic selected, and there's actually 3 buttons in the bottom that we can use right now. You can send data to that characteristic, you can retrieve data from that characteristic, and you can register to that characteristic if it has notify enabled. Now this first characteristic does have a notify function, so I can go ahead and select register. And it says there in the bottom, notify callback function registered successfully. In addition, in blue, we can see that bytes are received from our ESP32 BLE device so that the callback function is actually working. Now, how does that work? Let's briefly go to the XAML page over here. Now, the 3 buttons are shown completely on the bottom. They're right over here. And when register is called, then the function register command button clicked is run. And that is the function over here. Now, what this function does, it first verifies obviously if there is a valid characteristic, and then we define a callback function. With notify, the server will periodically send data to the client, to our app. And whenever information is received, we want that characteristic to update the information received and write it to the screen. That is done by defining then a callback function that's run every time new information is received from the server. It receives bytes, and it doesn't know what those bytes are. So in this callback function, I will show you various ways to interpret the bytes that you receive from the server so that you can select the method that you need for your code. Now, the received bytes are received in the arguments of that callback function. That is here args.characteristic.value. So we retrieve the bytes by writing that to here our received bytes. For debug purposes, the first thing I do is write it to the console so that if you are in debug mode, you can then see that in the debug section. At the moment, I am not in debug mode because that way I can navigate more easily between the XAML page and the code behind. So I cannot show you this at the moment, but you'll see that yourself. So that now there's different ways to interpret the received bytes, and that we do over here. The first thing we do is we just write the bytes to the screen as is. That's done over here, so we need to of course make sure that actually something has been received, and then we write to the screen the bytes as is by converting them directly to a string. That is the first section that you can see here, where you basically see a hexadecimal representation of the bytes received from the least significant byte to the most significant byte. Then subsequently, we try to interpret the received bytes as an ASCII command. That's done over here. Well, in this case, it's just a simple counter that updates every so many seconds. So that's where we see that the UTF interpretation is not really something useful. Finally, the received bytes are interpreted as an integer. How that is done is shown over here. I limited the received byte length here to 4. The reason for that is that you get to incredibly large numbers. If, for instance, you receive 32 bytes and need to represent that as an integer, that probably is not very useful. Here we need to reassemble the least significant to the most significant byte into one integer, and that is done by bit shifting as follows. So we cycle through the received bytes and then move each byte up with 8 bits. We get an integer out of that and we update our string, char string. Then finally, the last thing we need to do is add a command break line and write it to the screen. That needs to be done in the main thread. So it's a multi-threaded application and we want to be able to access output.txt, and we need to do that in the main thread. So that's where we run this Xamarin Essentials main thread function and then update the output.txt with our char string. We now defined our callback function that starts over here and it ends right over here. Now we need to make sure that our characteristic calls this update function whenever an update is received. And that we do by calling this asynchronous function start update async. Finally, when something goes wrong, we of course update our error label. Now let's look into manually sending and receiving bytes. I'll briefly clean up the screen here and reset our program so that you can clearly see receiving and sending of bytes. Now let's briefly go to the XAML page, and there let's have a look at the different buttons for receiving and sending. We see that when we press receive, the function receive command button clicked is run, and when we press send, the function send button clicked is run. And those two functions are over here. The send button, in essence, takes the string that is inserted here in the bottom. You can see there ATZ, and you can change there whatever you like. And we can see that also in our XAML page. We have here this entry called command text, where you can write your own string. So we take that particular string, convert it with ASCII coding to bytes, and send it to the characteristic. Similarly, the receive command button, here we receive the bytes from the characteristic, and we then convert them back with ASCII coding to a string and write that to the output text. So I can go ahead and send and then receive, and we see that we receive our ATZ string back. I can now go and change the string and again send and receive, and then we get our updated string. So that way you can also manually read and write to characteristics. So this example tried to show just all different ways to communicate through BLE. I'm sure in your own program you'll be using these in a different way, and I hope this was insightful for you. I tried to also add a lot of explanations in the code itself to just help you get on your way. Xamarin definitely is not the most straightforward language to program with, but once you get the hang of it, it's really worth its while. So I hope this video was insightful for you. Please hit that subscribe button, likes well appreciated, and see you in the next video.